Thank you, Murnaz.
Yeah.
All right, we'll get started and he'll join us. Okay. Hi, everybody. Welcome to the last session of the conference. Really glad that you've been with us this whole time and that you're here for this last great session. I'm really interested in cloud storage or of our storage. This is something that comes into my daily life all the time. So I'm excited to hear more about this topic. So today we have Kevin Kettner and Casey Schacher, and then pretty soon we'll have Rushabh Vora with us. And they have a pretty long presentation with lots of great information, and we want to make sure that we have time for our questions. So I'm going to turn it over to them. But if you have questions throughout this session, go ahead and type them into the chat. Kevin said that he'll be able to answer some of them, or he'll be monitoring the chat to be able to answer things as we go along. There's Rushabh. And we will then make sure we have time for questions. And I will be probably speaking some questions, but we'll probably be doing most of our questions off the chat. So again, thanks for joining us. And I'm going to turn it over to the three of you. Thanks.
Great. Thank you so much. Okay, I'm going to do what I think is sharing my screen. Kevin, could you confirm that you see
I sure do.
the presentation full screen?
It's great.
Okay, wonderful. I shared the right one then. Welcome everyone to a presentation about Research Object Storage S3, which is an on-premise storage service offered out of DoIT. My name is Casey Schacher, and I am the research storage lead for a unit within DoIT called the Research Cyber Infrastructure. And I am joined by a couple of my colleagues. Kevin, could you introduce yourself, please?
Yeah, I'm Kevin Kettner. I'm the lead for enterprise storage and data protection at DoIT.
Hi, I'm Rushabh, and I was the former RCI project assistant and current UW-Madison alumni. And yes, I'm looking for full-time data analyst and data scientist role as well.
I can vouch for him. Okay, so today we have a full schedule. We're going to give a brief overview of the storage services offered through DoIT, as well as focus in on the research object storage service particularly. And after that, I would say the heart and soul of this presentation are going to be the demonstrations that Kevin and Rushabh are going to do. So Kevin's going to show you how to interact with research object storage using a free file browsing application called Cyberduck. I believe, Kevin, did you go ahead and put that chat in the chat, the link in the chat? Okay.
I put that in there, and a lot of this presentation is designed around the research object storage, but you can use it for non-research things too.
Very true. So if later during the demonstration you're wanting to follow along, I encourage you to go ahead right now and download the Cyberduck application so that you'll be ready to go when Kevin takes over. And then Kevin's going to pass it off after that to Rushabh, who's going to do a demonstration on how to interact with research object storage using a Python library called Bodo3. Very cool stuff. But before we get there, let's talk about what are some of the research storage services offered through DoIT. Many of you might already be familiar with Research Drive, which is secure shareable data storage for researchers. Some of you might also be familiar with the departmental equivalent to Research Drive called Shared Drive. And so a Shared Drive and Research Drive share the same backend infrastructure, the hardware, but they're configured on the front end for different use cases. For Research Drive for researchers, and then for Shared Drive, departmental or unit use cases. We also offer a service called Globus, which is a data transfer and management tool. I'll talk a little bit more about that at the end, but the majority of this presentation is going to be focused on that third bullet that I skipped over, Research Object Storage, which is a storage service that we just rolled out last year. It's great for archiving and automation. There is a departmental equivalent called Object Storage, and I'll kind of go over those all in detail. First, though, let's talk about Research Drive. So Research Drive, I wanted to talk about Research Drive because one of the main questions I get is, can I get research object storage if I already have Research Drive? And the answer is yes. We actually require Research Drive, people to have Research Drive in order to get research object storage because they're complementary storage services. They're not competitive. And so they have different use cases. They're meant for different things. And hopefully by the end of the day, you'll have a pretty good sense of what those are. But It is secure. It's fully compliant for restricted data. You can also share it. It doesn't have some of the nice collaboration features of something like Google Drive, where you can use Sheets and Google Docs and things. We don't have that, but you can share your research drive with your lab members so that you have a shared storage space. And the storage service offers 25 terabytes of no-cost storage. That means free storage to eligible researchers. And eligibility means basically tenure-track faculty members, research professors, or a special class of academic staff called permanent PIs. There's only about 50 on campus. There are a bunch of other people that perform research on campus that don't fit into those 3 titles. And if any of them are what we call lead PIs, now PI stands for principal investigators. It's a specific role that people serve on funded research. If somebody is a lead PI but don't fit into those 3 categories, there is a path towards eligibility for them. And they just need to fill out a separate form, which allows them to describe their research program, and we can approve them then. If anybody needs to have an account that isn't a lead PI or a tenure track faculty member, we can offer accounts to any permanent staff member. It would just be fully billed. So for anybody that's on a fully billed account or have kind of exceeded their 25 terabytes of free storage, people are going to be paying $120 per terabyte per year for that additional storage. All right, we've onboarded already about over half of eligible researchers on campus. So we have over 1,300 PIs onboarded into Research Drive. Research Drive came out in about 2019. So it's been around quite a bit longer than Research Object Storage, which we rolled out to campus late last year. Collectively, those PIs are storing over 8,600 terabytes of data across the 2 storage services. So another question that I commonly get is why? Why did you create this storage service when we already have Research Drive? Well, this is the answer. It's because our original goal with Research Drive was to meet about 80% of users' needs on campus. We really wanted to catch as many use cases as we possibly could with one tool, but we did know at that time that there were use cases that weren't being covered by Research Drive, namely big data users, people that are working with enormous amounts of data. And I just want to acknowledge the fact that the RISE initiative is going to increase the amount of big data users exponentially in the very near future. And so we were aware then and are continuing to be aware of this growing need for big data storage, compute pipelines, things like that. And so Research Object Storage was born out of our need to grow with that campus growth. So Research Object Storage, what is it? It is an on-premise, meaning UW-Madison local hosted S3 object storage service. So when people hear S3, they often think, oh, AWS Glacier, is that the same thing? And so I'm here to clarify, this is not AWS Glacier. This isn't a public cloud storage at all. It's on-premise. However, it is based upon the AWS S3 protocol. And so that's a good thing. The AWS S3 protocol is really popular. A lot of things just speak natively to S3, web applications, instrumentations, Internet of Things devices. And so there's a lot of just native integration already available. But I would say the biggest use cases that we're seeing to date are for data archiving and setting up compute to storage pipelines. You may be wondering, how is Research Object Storage different than Research Drive? There's a few key differences. I won't go through all of these because we are time limited right now, but I will say that Research Drive supports restricted data. Research Object Storage does not yet. Support for restricted data is on our roadmap, but we're just not there yet. So it's not available for restricted use cases. It is a lot cheaper. I'm going to go over the pricing in a minute. I would think that the third biggest difference is that data protection bit down there. Kevin will talk a little bit more about this when he demos Cyberduck, but there's some big data protection differences that are honestly one of the reasons why Research Object Storage is so much cheaper, but they do have some big considerations for what types of use cases that you should really be using this service for. One of our colleagues, Philip Daudet, likes to put it this way. If you have human-centered workflows, like people are getting in there and interacting with the data on a regular basis, then Research Drive is your answer. If you have computer-centered workflows where you do not need humans to access the data very often, or you're just going to put the data somewhere, archive it, and forget about it for a long time, Research Object Storage, it might be something to look at. Of course, Research Drive can also be part of a computer-centered automated pipeline, but research object storage is really good for situations where humans don't need to touch it. Okay, so pricing. Research object storage, like I promised, is much cheaper than Research Drive. Whereas Research Drive, you get 25 terabytes of no-cost storage. With Research Object Storage, eligible PIs get 50 terabytes of no-cost storage. For additional storage or for people that aren't eligible, the cost is $60 per terabyte per year. So any permanent employee can get an account, but it's $60 per terabyte per year, fully billed. Departments can also take advantage of this service. It's branded a little bit different, kind of like Research Drive and Shared Drive are different branding of the same thing. We brand the departmental use case as just object storage S3. And so it is available, no subsidies included in the object storage departmental version of this service. However, the departments are able to take advantage of this nice pricing structure of $60 per terabyte per year. One of the ways that research object storage differentiates itself from something like AWS Glacier is that there are no hidden charges. With Glacier, it's really cheap to upload. And so if you have a situation where you have research data and you just need to stick it somewhere and forget about it for the rest of its life, Glacier is definitely something to look at. It's very competitive pricing for uploads. The gotcha comes when you need to download that data. So if you need to access this data on a semi-regular basis every few months, once a year, once every couple of years, definitely take a look at some of those hidden costs with other S3 services. Research object storage is nice because you pay for what you use and we don't care what you do with it. You can upload, download to your heart's content. And there are no hidden costs at all. So I already covered eligibility. I won't go into it anymore, but if you need a refresh, slide 14 includes the eligibility criteria for research object storage. I will mention that IT or support staff can get a support account for research object storage. It does not offer, it's free, but it doesn't offer long-term storage. So it's not a place that you can take advantage of for long-term storage, but it is a great way to learn how to use the accounts and to kind of get familiar. So when you're supporting your department's PIs. All right, so wanted to just give a few examples of how people on campus are currently using the service. There is a department, the Department of Forest and Wildlife Ecology is collecting a ton of environmental data, lots of data. And they had a problem. As their data grew, so did the cost of storing that data. It became really expensive. They were storing most of their data in Research Drive. And so when we offered research object storage, they were able to move over a lot of their archival or inactive data to research object storage to realize a cost savings of over 60%. There is a lab studying plant genetics that was wanting to set up compute pipelines. This is that second use case I mentioned. That's one of the more popular use cases for this tool. They wanted to set up compute pipelines between research object storage and the Center for High Throughput Computing because they were wanting to run analysis on drone images and drone video. And so they were able to set up these pipelines so they can take advantage of the lower cost storage, but also take advantage of the free compute resources on campus. Okay, so the Sound Forest Lab is another example. They're an example of application integration. So this is a really cool application where people from all over the world can upload audio samples, audio recordings of a forest and that type of sound recordings. And so the storage that's underlying this, that stores all the data that's uploaded, that's research object storage. Okay, and the last example I'm going to share with you is out of the state cartographer's office. So they've got, similarly, they've got a really cool website that allows you to go and access aerial imagery data for Madison and the greater Wisconsin. So you could see what it looked like, our Madison looked like from sort of a bird's eye view throughout history. And all of those images are stored in research object storage, but they've built this application on top of it that allows the public to access the images. Okay, so the last thing I'm going to talk about is Globus. A lot of people are using Globus. It's a very popular data transfer tool that allows you to transfer data from point A to point B. And it also is a tool that's commonly used to set up automated pipelines. And so one of the big questions I get on a regular basis is there support for research object storage in Globus? And my answer is kind of. So we currently have temporary Globus collections set up for research object storage. And you can see the temporary collection name listed here in case you're interested to use it with your research object storage account. It is on the campus access pool, which might mean nothing to you, but Kevin will talk a little bit more about that in a second. This is temporary, meaning that it eventually will be replaced, decommissioned, and replaced by a permanent collection. So we don't encourage anyone to set up automated workflows using this temporary collections, because in the future that will break. We'll notify people before we do this, but those automated workflows would break and would need to be redone. So we don't encourage that. Also, we have no high assurance collection support. High assurance is for restricted data. Makes sense because we haven't rolled the service out yet for restricted data. So that's the end of my piece. I'm going to pass this over to Kevin.
Hello. So I'm going to do a little demo with Cyberduck. I put the stuff, the instructions to download it and some keys into chat. And now I'm going to do that again. And I'm going to put my entire little slide notes so you can know what I'm going to talk about. And if I forget anything, you can remind me. I'm going to share my screen. I've got a little VM that I created to do this demo. So you should be seeing Cyberduck and a Windows 11 VM that's just pretty vanilla. Has everybody seen that?
Yep, we can see it.
All right, great. So first thing, what is Cyberduck? Well, Cyberduck is a client that allows you to connect to a bunch of different types of file servers and protocols. S3 is really a REST-based API that runs on HTTPS. So if you want to work with S3, you either have to be really good at writing curl commands or use Postman or use some kind of client that knows how to work with S3. So what I'm going to show you today is the thing that we're basically telling you that you shouldn't be doing on a regular basis, which is doing human interaction with S3 buckets. It works a lot better when you do that interaction with through some kind of application or some automated process. So that's Cyberduck. What are buckets? Buckets are the containers that S3 is based on. So when you have an account in S3, you can create and delete your own buckets, and the buckets are where the data is stored. When you connect to S3, you need to connect through an endpoint. We have two endpoints that we're going to talk about today. One is the web endpoint, web.s3.edu. That endpoint is available off campus. And then we have the campus.s3.edu, which is firewalled and restricted only to campus. So if you have data that's more sensitive, that's where you're going to want to store that and not, and it has a little bit more protection than the website does. The next thing is what are keys. So in order to connect to a bucket, you will need to have a key to access it. The key, it's made up of an access key ID and a secret access key, and those are like a username and password for the bucket. A lot of times these will be something that you'll just configure in an application that talks to S3, but sometimes you need to know them so you can connect it with clients like Cyberduck or whatever. So let's go ahead and start out with creating a connection. So I've got Cyberduck running here, and this is not pre-configured at all. So I'm going to just hit this open connection button. Then I'm going to choose from this protocol list at the top, Amazon S3. And then I have to type in my server. Don't worry about HTTPS, that'll just fill in automatically. So I'm going to put in web.s3.wisc.edu. Then I need my access key and secret access key. These are generated randomly. We don't really get a choice. You just press a button and it generates them. So if you want to have custom ones, sorry, you can't. Once I fill those in, then all I need to do is hit connect. And now I will see the list of all the buckets that exist in my account. Each bucket is attached to a certain endpoint. So If I create a bucket because I'm attached to the web, it's going to get created in the web endpoint. If I create a bucket and I'm connected to the campus endpoint, it'll create it on the campus endpoint. I will be able to see the buckets on both sides, but I won't be able to access them. So this bucket was created on the campus endpoint, and it won't let me access the data from the web access point. Okay. So let's go ahead and create a bucket. I'm going to move through this stuff pretty fast, but we may be able to have some extra time at the end if you want to see some stuff again, and please feel free to play around with this, create your own buckets, and do whatever you need to as we go. So I'm in the root of my account here, and where I can see all my buckets. If I just create a new folder, and it doesn't matter which region you pick here because we only have one region and it doesn't really care. So if you create a bucket, please append something like your net ID so it's unique. Every bucket in the system has to have a unique name. So I'm going to put in Kettner dash demo dash 1. Hit create, and now I have a bucket. I'm going to go ahead and create a second bucket right away, just so you can see that again. I'm going to click outside of the other buckets, new folder, Kettner dash demo dash 2, and now I've got a second bucket to show you something else. All right, so now I've got 2 buckets created. If I want to upload files, I can just kind of browse through this. You can either like use these arrows, or the best way to do it is to double click, and then now I'm inside of that bucket. So if I want to upload a couple of files, I can drag and drop them. So I have this demo folder here. I'm going to upload these 2 files directly to the root of the bucket, and now they are uploaded. If I wanted to upload this entire folder, you can also drag and drop a folder, and it will upload the entire folder all in one shot. So that's uploading files. To download files, it's the same way. You just drag it back out, and it'll download it. So one of the things that you can do with buckets is you can, especially on the website, you can make web links to your files that you can share with anybody in the world, basically. So if I want to do this, we have to add the everyone permission to your file. So the files do not have any permission to be accessed outside before I do this. So I'm going to, in Cyberduck, if you right click on a file, you can do this copy URL or open URL. So I'm going to open this URL. It's going to open in Firefox, and I'm going to get a permission denied error. There we go, access denied. So I want to make this available on the web. So I'm going to go to index. I'm going to right click on this, or you can use this get info button at the top. I'm going to go to the permissions. There's this little gear on the bottom. I'm going to open this up. I'm going to add the everyone permission. And then I'm going to change this to be read only. We do not want to give full control to everyone on the internet, to our buckets or to our files. Then I close this, and that's going to assign that permission. So now if I reload this, and you can see my static website contact demo. And there's an image here, which is not loading because I have not yet assigned the everyone permission to this image. So I'm going to do that right now. Again, we go to this little gear, we add everyone, change this to read, close it, and now we can see the UW Press logo that I downloaded. So that is the everyone permission on files. If I do everyone permission on a folder, it works a little differently. On the Windows client and the Mac client, it does also work differently. Files that exist on a Mac client will get a recursive permission change. On Windows, it doesn't seem to do that. So if I add everyone permission to this folder, and I change it to read, I go in here, and now I open this URL. I still get access denied because the permissions are not inherited from folders. Okay. If I want to give everyone permission to an entire bucket, though, then permissions are automatically inherited, and any new files you added are also inherited. So if I go into get info on this bucket level, I go to everyone permission. Make sure you give it to read-only access. We don't want to give full control to everyone in the world. Now, if I upload my files, oops. Did a fresh upload. Now these files are going to automatically inherit permissions without changing them. So I go to open URL, and now you can see, or you will see, this is bucket 2, and it should show you my content. Of course, it's being a little slow. So that is the everyone permission and web URL sharing. So if we want to remove the everyone permission from a file or folder, let's go back to the original one, and let's remove the permission from this one. Go to get info here. Click the one we want to remove. You should be careful to not click the owner and the full control. You actually can remove them, and that removes your permission to the folder. So we're going to click everyone. Back to the gear, hit remove, close it to save it, and now this crest logo should disappear because there's no longer has permissions for it. I don't know why this one is claiming to be taking so long, but trust me, it does work. So let's see. Can I use the everyone permission on campus buckets? Yes, you can. If you assign everyone permission into files or folders on campus buckets, those will still allow anyone to be able to see them, but they will have to be on campus IP space. The next thing I want to talk about is bookmarks. So bookmarks are really handy if you want to be able to reconnect to your different folders or whatever, so you can connect directly to a bucket or just to the account. So if I want to create a bookmark, you browse to wherever you want to be for this bookmark, because it's going to do it automatically that way. Go to bookmark, create a new bookmark. You have a chance to edit this, so I can call this demo bookmark. Go ahead and close it. And now when you open Cyberduck, you'll see this list of bookmarks, and you can double click it, and then it will connect back to where you were. You can change, you can create a bookmark into a specific bucket or anything like that. So the next thing I want to talk about is versioning. So what's a lot different between S3 and Research Drive is the way that data protection works. So in Research Drive, we have snapshots and replication that do a really good job of protecting you from just about most threats that are out there. S3, however, it does not have snapshots. It does have a thing called versions. I mean, it also has a very good site-based protection. So there's all of your data is copied using erasure coding to 3 different sites in such a way that we could lose a full site and it would not impact access to your data. So in that way, it's actually superior to Research Drive. But versioning, it works a little bit differently. I'm going to show you that right now. So if I go into my bucket, actually, sorry, I want to go to the bucket. I have to first enable versioning on the bucket. So any bucket that I create, if I want versioning, I have to enable it. So to enable versioning, you go to get info on the bucket, you go to this S3 tab, and then you check this box to enable versioning. You can ignore this life cycle thing down here. This only works with Amazon. This part of the API for our S3 is not compatible, so you won't be able to use this. Rushabh is going to show you how to do a set of versioning lifecycle policy in Python, though. So I close this, and now versioning is enabled on my bucket. So I can go into my bucket. If I want to see the versions, I need to go to View and then do Show Hidden Files. Now, if there's any extra versions, I'll be able to see them. So if I go ahead and upload a file, even if it hasn't changed, I'm going to pull this index.html back over there. It's going to ask if I want to overwrite it. Yes. Actually, I pulled both of them over, and now you can see a little grayed out version that's a previous version. Even though there's no change at all, I've got a new version. The same thing happens when I delete a file, or I can upload this as many times as I want, and there's going to continue to create versions. If you do not have a bucket lifecycle policy, these versions will exist forever until you delete them. A bucket lifecycle policy tells it to delete versions after a certain amount of time. So if you need to revert to a version, so I made a change to my index.html and I don't like it, you can right click on it, you can go to that version, you can hit revert, and then it will make that the new current version. You can see the time updated here, and it will keep the version that you didn't like along with all your other versions. So now I have 4 versions of the same exact index.html file. In S3, there isn't any data deduplication or compression built into it. That's why it is significantly less expensive than Research Drive. So any files that you have multiple copies of, you will that will count against the quota. If you're in a fully billed account, all those copies will be billed. I've got all these versions now. I'm going to accidentally delete this file. So now you can see that there's 4 versions here, and then there's this extra file that is actually a delete marker. If I want to undelete these, I can just delete this delete marker. And then now my last version will now become the active version. If I delete this again, I can also use the revert feature to, let's go back and revert to this one. That will also bring back this version of the file and make that the most recent version. That's versioning in a nutshell. Don't forget, you have to enable that on the bucket if you want it. And if you don't set a version lifecycle, it will take up as much space as it needs to for every single file that you have a version of. I think that's it for what I was going to cover. Did I forget anything, Casey or Rushabh?
No, thank you. That was great.
All right, I'm going to stop sharing my screen and I'm going to hand this over to Rushabh to show you how to do some of the same stuff in Python.
Thank you, Kevin. So now whatever Kevin has performed in the Cyberduck, so now we will be seeing that live into the Google Colab notebook, and I'll show you how we can do that using the code. So I have already pasted a link into the chat box, so you guys can go ahead and open that link. Meanwhile, I share my screen. Okay, I hope my screen is visible.
It is.
Yeah. So now what I want you guys to do is, once you have opened that link, I want you guys to go to File and then save a copy in a drive. So that way you guys can work in your own environment, and that way we don't have the conflict when we are using the same file. So you guys can go ahead and save a copy into the drive, and it will automatically create a new copy into your drive. So once that is done, then we can go ahead and start working into our code. So, like I'll walk you through how we can interact with Research Object Storage S3 using Python and Boto3. And I'll be running everything live in Google Colab. So this is entirely browser-based and portable. So first thing is that what exactly is the Google Colab? And so it is a free cloud-based platform that lets us write and run Python code in Jupyter Notebook environment, all from our browser. So we don't have to do anything locally. So why do we need API integration? Like now, Kevin has already, we already saw the demo that we can do everything into the Cyberduck. Then why do we need the API integration? So as Kevin said that we cannot apply the life cycle, correct? So that's why that's the one thing where we can use this API integration Python based, and also it helps us minimize the human error. Suppose you are working for a very large files, then how are you gonna manage it? Like you are not going to go manually and look after those files, right? So that's why it is a very useful tool, and I'll show you that how we can use it. So first thing first, that what exactly is Boto3? So Boto3 is an official AWS software development kit for Python, and it helps us interact with services like S3 using simple Python code. And in this demo, we are using it with the UW-Madison's S3 endpoint URL to manage our data storage. So you guys can go ahead and you will see that first we need the libraries installed, right? So without that, how are we gonna interact with the API? So we'll go ahead and install this library. You guys can go ahead and hit this cell. So it will automatically run this cell. And here I am specifically installing this version of the Boto3, which is 1.35.31. The reason behind that I'm not using the latest version of the Boto3 is that there are some limitations to the new version, and probably some of the features might work or might not work. So which is why we do not have that proper documentation yet. Probably in the future we might have. So which is why I'm using this like previous version of the Boto3. So you see that it will hardly take 10 seconds to run all this, run this, and it will install this Boto3 library into your environment. So once this library is installed, now like one thing about Python is that we have to import all those modules. So once we have all those modules imported, then only we can start working with those libraries, right? So we bring in these requests and hashing utilities to support lifecycle policies. We'll look after it later, that how we can use this into our into applying the data lifecycle policy. So you guys can go ahead and run this cell, and you will see that okay, so this we have already imported all those libraries. So now we have libraries installed, we have imported all those libraries, but now how do we go ahead and integrate our all of our keys, and what Kevin has already shared with us, how he showed that we are doing it using the how we establish the connection using the Cyberduck. So it's really simple over here, that I am just passing out the key and secret access key. So now note, like this is really important. You should never ever hard code these credentials over here. So I am only using this just for the demo purpose, but you should never share your credentials like that when you are working in the organizations or working in the group. So you should always save these credentials into the JSON file or YML file, and then you guys can import that file into your notebook. So that's how you can go ahead and do not hard code these credentials. So once I have coded these credentials over here, and here is the endpoint URL which I am hitting, so which is web.s3.vis.edu. So now what if what if I have these credentials incorrect? How am I going to do it? So now let's say suppose that these are the incorrect credentials. So when I run this code, you will see that it failed to establish the connection, right? Because it says that error occurred because like signature does not match. So you guys can, that way you can know that credentials are incorrect, and then you can go ahead and rectify your credentials. And when I hit run, these are the correct credentials, and you can see that, okay, connection has been established successfully. Same goes with the endpoint URL as well. If suppose you have endpoint URL which you have added is incorrect, then you are going to get the same error again. So once our connection is established, now here is the fun begins. Now we can actually start interacting with our API. Now I want to list all of the buckets which are in my Cyberduck. How am I going to do it? So we have that function, like we are going to call it using our Boto3 library, which is list buckets. And this will help us list all of the buckets which are present in our Cyberduck. So I'll go ahead and run this cell. And you guys can see that these are the buckets which I have present. And same way, we can go to the Cyberduck and verify that are these the same buckets which we have? Yes, so these are the same buckets which we have, right? So Kevin just created this demo1 bucket and demo2 bucket. You guys can see that these are the buckets which he just created, and by running the code, we do have these buckets. Now, after listing all of these buckets, what if I want to actually see that what's inside the bucket? Because you also want to see the content inside the bucket, right? So I want to see that what's inside my demo bucket. So I'll go ahead and change my bucket name over here. I'll pass in the bucket name. And this function from Boto3, which is list underscore objects underscore v2, it will help us retrieve all of the files which is inside the bucket. So when I go ahead and run this file, you will see that yes, it has one of the file which is iris.png. Again, I can go to the Cyberduck and see if there is file present into the bucket or no. So here is the demo bucket, and when I go into that bucket, now again, one thing I want to let you know that the Cyberduck which I'm using, this is the Mac version. So don't get intimidated that you have the different kind of UI which you are looking if you are using the Windows. So this is going to be different. So now you can see that, okay, so here is the iris.png file, and we also saw that using the code as well. Now, what if there is some buckets which doesn't have file? Now, if let's say that this bucket, it doesn't have any files, right? So if I go ahead and run this code, it will say that no files found in this bucket. So that's an activity for you guys. You guys can go ahead and try it out. You guys can create your own bucket. Now we'll see that how we will create our own bucket and see that what if we have content within that file or not. So now let's say you want to create a new bucket. Now we have that function into the Boto3, which is create underscore bucket, and this will help you create bucket. So I have called the function 2 times, and I'll let you know that why am I calling it 2 times. So I want you guys to go ahead and change your change with your net ID. I'm using my net ID over here, so you guys can use your net ID. But yes, one thing is that it has to be unique across all the S3 accounts. So which is why I'm telling you to use your net ID so that there is no conflict. So when I run this, you'll see that these buckets have been created. Now, again, I'll go ahead to Cyberduck and verify that are these buckets created. I'll go ahead and refresh, and you guys can see, yes, bucket 2 and bucket 3, which I just created, I can see it in the Cyberduck. So once these buckets are created, now what if I want to delete some bucket? Now I want to delete a bucket, which is this bucket. Now, I don't want that bucket. But one thing about bucket is that you can only delete a bucket when it's empty. You cannot delete a bucket when it has content within those buckets, or you have objects within those buckets. So when I go ahead and hit, oh, I'm getting an error. So what is the error? Oh, so the error is that the specific buckets does not exist. Yeah, that's true, because I guess I can go ahead and verify that do I have that bucket? No, I do not have that bucket. So I can go ahead and rectify and I can pass on my appropriate bucket name over here. So I want to delete this bucket, which is 3. And I will go ahead and provide this appropriate bucket over here. And yeah, see that there were no files found and the bucket was deleted successfully. And I can go ahead and verify over here, and you can see that you will find no bucket over here. So now what I want you to do is I want you to uncomment this cell. You can just remove the hash over here and try to run this file and see what happens. So this has the files. So it will first delete the files within that bucket and then delete the buckets. So that's what this code does. Now, what if I want to upload a file to my buckets, right? So as we are using the Jupyter, like Google Colab, we will be using the local files within those Jupyter notebooks, right? So here we have this local files over here, and it has the sample data over here. So we can go ahead and use any of these files which I want to upload. Let's say that I want to upload this file to my bucket. So I want to upload it to my second bucket, the bucket which I just created. Now here is the local file. I am providing the local file over here, and this is the bucket name. So this is the bucket which I want to upload my files to, and this is the name of the file which I want to keep. Now we'll see that how it goes. Now I'll go ahead and run this code. It will take a little time because it's a bit larger file. And you see that, yes, like the file has been successfully uploaded to this bucket. I'll go ahead to Cyberduck, and again, I can verify this. You guys can drill down to this, and you will see that, oh yeah, so this, the file has already been uploaded. Now, what if I want to download some file from the bucket to my local file? So we also have that function in the Boto3, which is download files, but again, you are providing the bucket name. You're providing bucket name from which bucket you want to download the file. So I want to download the file which is within this campus research data, which is my bucket name. And I want to download this file, and this is the path where I want to download this file. So you will see that this file will be uploaded over here. So you guys can go ahead and run this cell. When you run this cell, you will see that it will extract, it will go ahead and get this file downloaded. So I can go and refresh over here. And when I refresh, you can see that, okay, here is the file which I just downloaded from my bucket. Now, as Kevin showed us that we can do versioning, right? Now, what exactly the versioning is? So enabling versioning in S3 allows you to keep multiple versions of an object. So it protects against the accidental deletes or overwrite. So which is why I'll go ahead, and here is the status which I am keeping, which is status enabled. And here is the function which I am calling, which lets you enable or suspend the version according to your needs. So I'll go ahead and run this cell, and you will see that, yes, version has been enabled to this specific bucket. Now, what if you guys don't want any versioning, and you want, like, let's say based on your requirements, now it changed that you want to suspend the versioning of the bucket. So again, I'll go ahead, I'll just change the status of this version, and I'll keep it to suspend. And I'll go ahead and run this code. And yes, so the versioning has been suspended for this bucket. You guys can go to the Cyberduck and verify the same. Now here is my favorite part. So as Kevin told us that this can only be done using the code, and that cannot be done manually. So this function applies the lifecycle rule to your S3 bucket that automatically manages the object storage. So it deletes the current version, current object after 60 days. You can set your days as per your requirements. So here I'm setting it 60 days. What if you want those files to get deleted after 120 days? You can go ahead and change that as well. What if you want to delete it after 30 days? You can do that as well. But 60 is the ideal days which I like to keep for my buckets. So I'm keeping it 60 days over here. Now, what if I want to also delete the older versions, right? So older versions, which are older versions can only be deleted like once you have the versioning enabled, right? So based on the XML rule structure, I'll set that concurrent, non-concurrent days, which are 30. So these are the rules which I am setting for my specific bucket. So I can go ahead and run this code. And you will see that, yes, so lifecycle policy has been applied. So all of your files or all of your versions that will be deleted as per the rules which you have set. So to wrap up, in this demo, we used Python and Boto3 to interact with UW-Madison's S3 compatible research storage. And we covered bucket operations like file uploads and versioning, and applied lifecycle policies using the XML request. So this setup helps you automate storage management and while maintaining data integrity, and it's very cost efficient at the same time. Thank you. You guys can have any questions, and we can take after that.
Thank you so much. Yeah, so I believe we're open for questions at this point.
All right. Well, while we wait for some folks to put any other questions in the chat, I don't think I caught like what type of I can sense that for some researchers on campus, a little bit of this could be a bit of a learning curve. What type of assistance can be provided for folks that are just learning how to do to manage their data in this way?
Oh, great question. So our team is a small team that serves thousands of PIs, but we are available to offer advice and assistance. However, I would say that your first stop for getting support is going to be your local IT. Local IT have been kind of briefed on the service and might be able to offer you some assistance that either we don't know about or we're not capable of given our small size. However, for instances where local IT either isn't available or needs some additional support, feel free to reach out to us. I'm going to put our support email address in the chat. And that's researchdrive@wisc.edu. That when you email that will submit a ticket to our ticketing system.
That's really helpful. Kind of along the same lines, is there a community of practice of PIs or graduate students that are using these services? Not that they don't need another thing to do on their plate.
Yeah, no, that's also a great question. So not currently. However,
Okay.
the research cyber infrastructure team is currently expanding. We're hiring a couple of new folks. And so that is an example of a type of activity that I'm really hoping that we can get into once we expand our team.
That's great. Okay, it looks like we got one from Andrew. Realizing this is still in development, but what controls will be needed surrounding object storage use with restricted data?
Let me take that one. So the S3 service and the S3 storage itself is actually approved for restricted data. We do have restricted data in our S3 that's been around since like 2019 in what we call vault mode. So this is called container mode, what we're offering for research. It's just slightly different, but the storage itself is approved. The key issue though is that most of the teams that are working with restricted data want to have some other things in place. For example, they would like to use it only through Globus because Globus offers some additional logging and things that this does logging, but the logs are kind of a pain because there's just so much of them to find anything useful. But the logging does exist. Globus has much better logging. Globus actually has NetID authentication, so you can see who's logged in and who's doing what with your restricted data. So we're kind of waiting for our new Globus hire to get our Globus stuff set up in a better state. So that we can roll this out for restricted data. So that's kind of what we're waiting for. It's not that you can't, it's just that Globus is going to be a better situation for restricted data in S3.
Thank you. And there's another question from Daniel. They are looking for some documentation on Bodo 3. So wondering if you all have a link to documentation for probably what needs to be the latest version. I think maybe they are not seeing the latest version for the documentation. So if you all have a link for that, that could be helpful. Any other questions that might be out there?
I will mention, I think Rushabh forgot to mention it. There is a bug in Bodo 3 right at the moment with our S3. And so if you notice in the collab, Rushabh specified a specific version. We had a ton of issues earlier this week and last week trying to get Rushabh's demo to work because it turns out there's a bug in the latest version that doesn't like to talk to our S3 on the upload side. So you can do everything else, but the upload is weirdly broken in the very latest version of Bodo 3.
Yeah, so there might be other things as well. So for the version which we have specifically used in the demo, I have provided the documentation. So that works perfectly fine. You guys can go ahead and check it out.
And Rushabh, it looks like you also, maybe you just said that, put the documentation link in the
Yes.
chat. Yes, okay.
Yep, it
Yep.
is there. Great.
I saw Sergio's question about non-degree employees be involved in
Oh, yeah.
research. So yeah, I mean, technically, I mean, undergrads or anybody can be involved in research. But you have to have a certain classification in order to get a research drive account with the subsidy. If you don't have that classification that Casey talked about, and she can run down those specific appointments, you still could use it if you're a full-time employee or if you're you don't have to be employed, but if you have someone who's willing to pay for the bucket and then give you access to it, or for their research drive PIs. So you do
If I
not
could
have
add
to. Go ahead.
I was just going to add a caveat to that. So part of the reason why we have these eligibility criteria is because of campus data stewardship policies that require the data that's produced as a result of research to reside in the account of the lead PI on that funded research. And so because of those data stewardship policies, we typically require that the lead PI is the account holder. However, people in their lab, other people that are collaborating with them can be added for research drive to their account. For research object storage, it's a little more complicated because access is controlled by access keys and not manifest, which is the application that controls access for research drive. And so if you have situations where you're needing to share out access with graduate students or other lab members, please do feel free to reach out to us and we can talk you through what that might look like. There are some options available. But Kevin is completely right that if there are people that aren't part of funded research, they're not in research labs, and they just want an account, there are options there. If they're a permanent employee, they can get a fully billed account. And I think I briefly mentioned it, but if you're a local IT, if you work in the libraries, things like that, you can get a support account, which is sort of like a demonstration account that allows you to learn the tool. It just doesn't support long-term data storage.
Yeah, with our demo accounts, or well, actually we used to call them demo accounts. Now they're called support accounts. You can, if you are an IT person or whoever, if you're a research assistant, right, you can get one of these, but please don't store any data in it. We do audit for that. You can throw some data in temporarily for testing and development purposes. That's great. That's exactly what it's for. But please don't, upload terabytes of data and then think it's going to be able to stay there forever. I did forget to mention about deleting buckets in Cyberduck. Rushabh showed you deleting buckets in Python. In Cyberduck, it actually will go and recursively delete all of your files as well. So if you go to a bucket and you delete stuff and it has files in it, it will delete everything. If you delete your bucket, it also deletes all the versions and everything with it. There is no way that you can recover the data after a bucket is deleted. It is permanently gone. So be very careful with deleting your own buckets.
Good tip. Any other questions out there? I don't see anything in the chat. Any last words of wisdom that the three of you want to share? Anything that you didn't quite get out in the presentation that you might want to share?
I just want to make sure everybody is like, you absolutely can use these keys and play around with this. Like that was kind of the whole point of us doing this demo. I noticed, I don't think I saw anybody create any buckets. So please feel free, go out there, download Cyberduck, create some buckets, upload some data, play around with a little bit, use Rushabh's collab, to do some stuff. And I will leave those access as long as I don't see some kind of abuse going on or whatever, until like maybe next week or something. So if you don't have time to do it right now, maybe you can work on it on Monday or something. So just, yeah, please go give it a try. That was kind of the whole point of the demo. So
Yep. Very good point. And this session is recorded. So if you want to go back and do the step-by-step by rewatching the recording, that could be really helpful. Rushabh, I think you had your hand raised. Go ahead.
Yes, so I would like to mention one more thing, that whatever I have showed you into the demo, so this is just the limited version of what I have shown. So you guys can go ahead and go to the documentation and see that what other things which you can do with the Boto 3. So these are the basic things which we do, but there are several other things as well, where you can just learn about the functions and play around with that. So that might be really helpful. So you can just explore the documentation. So other things that might be helpful for you.
That's great. Thank you so much for the three of you. It looks like we're at time. For everybody who joined us, I shared in the chat a link to the survey for the conference. So if you have a minute, please fill that out. I'm sure you'll get lots of emails about it later on in the coming days. But take a moment while it's still fresh in your mind and complete the survey for the conference. Thanks everybody for joining us and joining the session. And a huge thanks to our three presenters. Super great information. And I know folks will probably be following up with you in your office. So yeah, thanks and have a great weekend, everybody.
Bye, thanks.
Thank you.
Bye.